like we got sound, so that's a good thing. The next one, you notice it goes from G81 to G83 in the book. There's a G82 cycle too. The G82 cycle looks exactly like this cycle right here. The only difference between the G81 cycle and the G82 cycle. The G82 cycle is what we call spot face counter bore. Okay? And when you're spot facing or spot drilling and counter boring out there on the drill press, when you get to your depth, what do you normally do? You pause for a second and then you come back up. That's the only difference. It's going to have a P value in it. So G82 line looks just like that, but it will have a P with a number, and that number represents how many seconds it's going to dwell. We're going to use a G82 today because we're going to spot drill this part. Okay, I know it's not there, but it is in WinMax. If I go to that help menu and I type in ISNC G code, those are preparatory functions, so I'm going to double click on that. If I come down here to G82, right there it is. There's the G82, the XY, the Z depth, the R plane, the P, and the feed. Okay, those are the syntax that we're going to have in that line. The only difference between it and the G81 is that P value, because it's how many seconds to dwell. A G81 is like I'm drilling through a piece of wood. Straight through, straight out. Straight through, straight out. No dwell, no stop. Make the hole, get out of the way. Move to the next one. G82 is going to pause for a second at depth, or 2 seconds, or 3 seconds, or 100 seconds, whatever P. If you put P100, it's going to sit there for 100 seconds before it retracts out of the hole. Just spin it. So if you fat finger a button and you accidentally put zeros after it, that's how long it's going to be. That many seconds. Okay. All right. And then, you know the G83 we're talking about. The G83 is a PEC drilling cycle. Now, we do the G83 with a Q value. The Q is a constant PEC amount, meaning that we tell it, if I tell it Q100, Q.1, 100 thousandths, that means it's going to come down, it's going to go 100 thou deep, it's going to retract and break the chip, it's going to go 100 thou more deep, and it's just going to keep doing that 100 thou at a time. The other option is the I, J, and K option, which I'm not sure if that's in here or not. But I do know it's in the book, so let's look at it there. The other option is the I, J, and K option. So the I, J, K is, instead of a Q, you would put an I. The I represents the size of the first PEC. So the first PEC, let's say we make it 1/4 inch. The K, or the J, how much do you want to reduce after the first PEC? So maybe I tell it 50 thou. So if it's 1/4 inch the first PEC, that means the second PEC would be a 200. The third PEC would be 150. And on down to whatever I set the K at, which might be 0.1. Why would you want an incremental reduction in how much it PECs as it's getting deeper in the hole?
So the drill bit stays on more straight?
No, not necessarily, but
It's going to be touching the sidewalls as it goes down more.
sidewall, and you got to get the chip out of there. You want to get the chip. When you get down in the hole and you got the flutes buried in the hole, you don't want to load the flutes up and break the drill bit off in the hole, because that's just a whole other can of worms. You know, we want to be able to let that incrementally break that chip and get up out of that hole. Okay, so we in here, this class, most of the stuff we do is 1/4 inch thick. All the book exercises, there's no deep holes that we're going to drill in here. So we won't use that, but it is good to know about. The CAD CAM systems, they've got that built in where you can program incremental PEC depths and set it up just the same way. But that's how that works. Okay. All right. So let's look at WinMax. Let's just kind of get started here, getting set up. Hope he's not dying in there. I'm worried about
He
him.
was talking about the TDC and
Huh?
the After Effects of it.
Over here, first thing I want you to do is I want to make sure nothing is open or in your WinMax right now. So the first thing I want you to do is go to Erase Functions, Erase Part Setup, tell it OK, and then Erase Tool Setup. and just tell it OK to erase all the tool setup info. I didn't want you opening anything. I don't want anything open on in your WinMax right now. In the program manager, if you have anything open, go over here and help close all programs. Okay, to where there's nothing open. Blank slate today. All right, everybody good? Okay, all right. So we're going to import our tool library in on its own. So what I'm going to do is we're going to go to the input button, go to the input screen, go to import export functions, and import export tool library. Now when we bring this tool library in, remember we created that backup of the actual tool library the other day. When we bring it in, after we've made sure everything's cleared out, we go to append tools to library. Not merge, append. Then you're going to navigate. Remember, I always go up there and minimize that so it kind of cleans everything up. And then I navigate to my ThawSpace folder. Class, this is section 2 for me. And then you should have a tool libraries folder there. If you click on that, you should see your tool library show up over here on the right. You're going to click on that and hit import. Then if you uncheck this little box here, you should see all 10 of your tools. Okay? All right, so we got all of our tools. Now let's go to our program manager. We've got a no name FNC file, right? Everybody sees that there because we closed all files. I want you to do a save as. Okay. I want you to come over here, minimize this. I'm going to keep saying it until I see everybody doing it. Minimize it. And then pop it back open and go to your ThawSpace folder. Okay, your folder. And then in your folder, now we're going to start saving stuff in lesson folders. So click on your folder over here, not your tool library folder, but just click on your name folder here, and then click create directory. And this is going to be lesson 4 CNC mill. Okay, to save it. And then now you should see that folder over here. It's a subfolder now in your main ThawSpace folder. You're going to click on that because that's where we're going to save this file at. So highlight it. And then come down here to the file name. You're going to make this your first initial, last name, dash lesson 4, part 1, .fnc. Make sure that you don't delete the .fnc. This is going to be the naming, the file name template that I expect you to follow. First initial, last name, dash the lesson number, dash the part or exercise number, depending on what it's called in the book. Sometimes they call them exercises. Most of the time they call them parts. So it'll be like part 1 of lesson whatever, part 2, part 3, part 4. You get the idea. But this is how I want you to name them. Okay, I don't want to see them just randomly named without your first initial last name. That's a big part of it. That's just like writing your name on a paper. Okay, if you don't put your first initial last name in the program name, I'm not giving you a grade for it. Okay, everybody can do this. All right, this isn't asking a lot of you. This is just about organization. Once you've got that, you can hit save, and you should notice back over here in the program manager, there's our file name and the path that it's going to. Over here, you can see that it's going from the T drive, my T drive folder, and into that lesson 4 folder, which is what I want to see. Okay. Everybody got it? All right. Let's double click on that. That's going to take us into part programming, where I'm going to make myself a little space. Take out your mill header sheets. Okay. All right. Now I've told you that on ours we don't have to put the percent signs, but I want you to get used to doing it. So we're going to go ahead and stick them in there. Okay, we're going to put our percent sign at the top. We have to have a percent sign at the beginning of our program and the end. If we put, and I do need to make this really clear, if you put the percent sign at the top and then you forget the one at the end, when you go to open your program, you're going to freak out because it's not going to show you anything. It's going to look like there's nothing there. Don't worry. Say, hey, I know this program is here when I hit save and now it's blank. Let me know. I'll come fix it. We have to open it up in a text editor and add that extra percent sign that's missing. Okay, you have to have them at the start and the finish. Because right now it's kind of got a weird boundary. It's got a start, percent sign, and then the end marker, which is also technically a percent sign. So we have to put both of them. If we don't put both of them, it'll be just like if you went and opened it on a control that requires it, and it's just going to be like there's nothing here. You know, because I don't have my syntax start and end markers. Okay, it has to have those. Then the next thing we have to have, Reagan, what's the next thing we have there on our header sheet that we got to have there?
The 0 dashes.
Capital 0, not a 0, sorry, capital O, letter O, and then the dashes represent the program number. 5-digit number. Here's how we number them. We name the file, first initial, last name, lesson number, part number. We number the file 004 for the lesson number, 01 for the part number. Scan cycles. Yeah.
Well, I think that we were creating the files.
Move you up to the front. One, nobody told you to create any of those. Close all these. Close all programs. Do that. Let's see if I'm because you're lying down playing in the comment section, so I missed this thing. Say that. Okay. Hey, I'm going to say a lot. Everybody got it? Is everybody good? And the reason I say that is because I know a lot of times that not everybody's not. But if you don't raise your hand, you don't make a motion like, hey, I'm going to keep rolling. Don't let me keep rolling if you're not there. That's when I want to pause. I want to fix it then, not 6 steps down the road and then got to get you all the way caught up. Okay, so please just be humble. Something's not right. I don't have that, hand in the air. I'll help you. If you wait until we're way away from where we were, sometimes I seem a little frustrated with it. Yeah.
Does that have to be all capitals or not?
Yeah, I keep my cap locks on when I program. I would prefer it. Truthfully, I would prefer that you do. Keep the cap locks on. Okay. All right. I'm going to put a / there, which is a block delete. It will hold that space there for me. It'll hold that space there for me. Then I'm going to open up my header sheet here on my page. There it is. Okay. Program name. We've got that in parentheses with the program number. The next thing it wants is our, what we call it? Our safety line. So we're going to put our safety line. Oops. There we go. So G17, XY plane selection. G20. What's G20, Ross? Come on, bud. G20. Inch coordinate. G40. Cancel cutter comp. G49. Cancel tool length. G80. Cancel can cycles. Everything we do in class together, I'm going to type a lot of notes and stuff, and I know some of you may not be as strong a typer as what I am. That's okay. Don't think you have to type all these notes. Anything we do together, I put on Blackboard for you. I give you. So if I write a program in here with you, it's going to be on Blackboard and you're going to have access. You're going to have the video. Okay, you're going to have video every day, every lecture. Now I got my sound working again. Every lecture, I'm going to send to you, and you're going to have lesson 4, part 1, can cycle from today. All right, you're going to have these. So if you know when I'm typing a lot of comments and stuff that you're going to fall behind, just don't worry about it. You can go back and get them later. Okay, you don't have to do it right away. I would encourage you to go study the videos. You know, rewatch them, redo things if you're not feeling like you're up to speed. Take your time, pause it, maybe even slow my voice down to 50% so I talk slower. Sometimes I talk a little quick. All right, you've got that prerogative. Okay, next thing. Our comments, our setup, our tools, our operations. So we've got some information we're going to plug in here. First thing I'm going to do is I want to go look at this lesson 4, part 1 on my book here. I'm going to go down to the print, which is right here. Okay, there it is. There's the print. My PDF does not have the same page numbers as you, but you should have this page you can look at. All right. So for setup, the XY0 is in the center of the part. Would everybody agree with that? I would. And then the Z0 is the top of the part. It tells us right there on the print. Most of the time as machinists, we get to pick that. You know, most of the time, they're not going to, the designer, the person that draws it's not going to tell us. In this book, I want you to follow what it says, and we're going to program off it, because sometimes it'll be the middle of the part, sometimes it'll be the corner, one of the corners, sometimes it might be off one of the features of the part, where maybe there was a hole that gets swept in, and that's where the origin's at. So on this particular part, it's in the center. Okay, so I'm going to put that right here. I'm going to say X, Y, origin, center of part. And then my Z origin, top of part. Not origin. There we go. That's just telling me, you know, edge find, comp to the center. Now that we know that, we're going to go do something else. We're going to go set up the stock. Because our softwares we use have a great tool, which is a graphics verification tool, to where I don't just create code and get to see lines of the tool moving. I'm going to get to see a 3D model of the part. I'm going to get to see it actually cut and do what it's supposed to do on the part. So what I would like you all to do here is go to part setup, which is this little button right here. Part setup, Control S will take you to this page. And something I want you to get used to doing in part setup. If you go to work offsets, I want you to plug in, and this should say what the NC state, so that'll also help out a little bit for you to remember. Put a negative 15 inches in all of the Z work offsets. Just put negative 15 in each one and hit enter. That'll say what the NC state. What are we doing? I'm basically telling it that if you leave them at 0, here's what it thinks it's doing. It thinks this is the spindle nose, and then it thinks this is your part, and it thinks they're like this when you start. Okay? We don't want that. We want it to be like the machine when the spindle's at home and the part's down here. We're basically saying it's negative 15 inches down to the part from where we start at. Does that make sense to everybody? We're lying to the computer to make it think it's an actual machine. Yeah.
And the shift.
Don't nothing in the shift. Yep, leave the shift 0. Just those work offsets. Okay. So
Click on it.
what's that?
Do you click on it to get it off? Because I'm typing negative 15 and I hit enter and it's just
Negative 15, enter. Minus 15. Just use the keypad over there. Put minus.
No.
Minus. There you go. Yep.
It keeps on going positive for me as well. Yeah.
What's that?
Use the keypad.
So if you I use the keypad. I think you guys are hitting shift. You don't have to hit shift for the minus sign on the numbers thing. Yeah.
I'm having a similar because I'm putting 15 and then it just goes back to positive.
So hit the minus and then 15
No.
first.
Use the keypad. I am. Damn it. I am. Oh, the right side. Number thing. Just helping me like stop being a dick every day. Finally, I actually got in there.
And that's all we're doing is we're setting it up for our NC state, making the computer think that you're actually at a machine and there's actually a gap between the tip of the tool and the part when we start out. If we don't put those in there, and we forgot yesterday, and everybody in the class went, because when we drew the part the first time, it had a hole in the part where it was just supposed to have a spot drill, because it thought the tool was sticking through the part already, 5 inches long, right? And it thought we were at 0, and it thought 5 inches of the tool was sticking, and then it had to go up from there. Freaked everybody out a little bit, but it was because we forgot to put that number in there. Okay, so if you start drawing it and it starts with like an end mill already through your part right when you hit go, it's probably because we're missing these numbers right here. Okay, we got to set it up to make it think we're a real machine. So we're gonna hit exit here. Part 0 here. This is the same as G54. Yeah. I do want to talk about it a little bit. This is G54 work offset 1. It's going to be the same as what we put here, okay, in G54. But if you make adjustments like to the shift here, like you're wanting to bring it down in Z, that does not apply to all the other work offsets. That only will apply to work offset 1 G54 with that shared conversational NC side offset. If you want to adjust it the machine out there, you got to do your shifts right here. I usually tell everybody don't use the shifts. I don't like them. I feel like a shift is a bad idea because if you make a shift and then you forget to clear it out, it's going to be in there every time you go out there and run your next part. And then somebody's going to cut something wrong. Okay, it might be you, might be the next operator. But I'm an advocate for making my adjustments in the actual work offset itself or the tool length. So, but that's all stuff that's application at the machine stuff that we'll talk about later. Okay. All right. Let's hit exit here. Let's get back to this part setup page. or you can just click on the button up here.
Oh shit. I accidentally hit it twice.
What's that?
The part set up.
Just hit the part setup button. It's no big deal. Okay. All right. We're going to go to more. And this is how we set up stock geometry. We go to more. We go to stock geometry. Okay. We're going to set up this stock. Now, this is a process. I'm videoing right now, so when you forget how to do this, again, you can go and you can jump to 25 minutes in the video and hopefully be able to figure this out again. We're going to tell it we want to do a box because this is a square part. We want to manually stock size it, so we're going to tell it yes here. And then we're going to tell it the length and the width and the thickness. Yeah. What's up? So part setup, more, stock geometry. You're going to get to doing this so much that you're not going to have to even think twice about how to get there. Okay? We're going to do it a lot together, but at some point, hopefully, you're going to have it. All right. So we're doing a manual stock size. So we told it yes, and that gave us all of this information for us to plug in our size of our stock. Got to make sure you hit enter. Had that happen yesterday. Somebody didn't have a thickness, and then when they had to draw it, there was nothing there, because if I tell it it's 3 by 3, but there's no thickness, well, there's no part, right? 0, 0. So for the length, it's 3, enter, and then the thickness, which is the Z, is 0.25, enter. So I typed in 3, I hit enter, typed in 3, I hit enter, and then I typed in 0.25. Okay, the reference point. By default, Herco's got their reference point on the front left corner of the part. That's where it's saying that's my origin for my draw screen, but what we know from our part is the origin is in the center. Okay, this is something that took me a while to get my head around. We're going to move the part, not the reference point. The reference point stays where it's at. We got to move the part to where we want this origin to be in the part. So where your head and where my head went when I first went to training at Herco on these machines was, well, I got a 3 by 3 part and I want to be in the middle of it, so I want to move 1.5 by 1.5 because I'm wanting to move the reference point. That's where my head goes, and probably most of you too, I imagine. But we're moving the part, so we're actually going to go up here and we're going to move the X reference negative 1.5 and the Y reference negative 1.5, and that shifts it to the left negative and back negative. Right hand rule, remember, negative, negative, and that's going to get our origin in the center. Okay, it's one of those things. WinMax, Herco, Mastercam, every software company I've ever worked with, truthfully, they've all got these little quirks that you're like, oh, why'd you do it that way? And the people that work there today will say, I have no idea why they developed it that way, but that's how it's been for 40, 50 years, and we have way too many customers to be changing it now. It's one of those things. All right? And honestly, once you get used to how it is, it's not too bad. You know, I still sit here and I'm like, man, that really should be the other way. Or like Mastercam, the work offsets in Mastercam, because G54 is work offset number 1 by our book, by our list, by everything else. But in Mastercam, when you pick your work offset, you put a 0 if you want work offset 1. Because the way Mastercam works is it takes the number you put in the field, and G54 is your first one, and whatever number you put in the field, it adds to the 54. So if you put a 0, 54 plus 0 is still 54. You put 1, you get your 55, 2, da, da, da. So, you know, just one of those things that we just have to get used to. And every control's got these little intricacies. Every control, every machine tool. None of them are perfect. I could sit there and pick apart every one of them out there. There's things I love about these. There's things that I see on a Fanuc control that I wish these had. There's things that are on this control that I wish the Fanuc had. Okay? There's literally, like, there's things on the Haas control I like. Okay? Probably get castorized for saying that, but there's things on the Haas control I do like. Okay, they've got some stuff I like. I like these better because I work on these all the time and I'm used to them. And that's kind of where most people are. Whatever machine tool you work on a lot, you grow kind of comfortable with and you learn about it, and then you got to change and you're like, oh, this thing's a piece of junk. And then you start working on it for a while and you start realizing, it's just another tool. It's just another machine. So anyhow, let's go back up here. And I didn't really speak on it, but I should while we're here. In the part setup, let's go back to that and let's go to the work offsets here because we need to know these. These are our work offsets. These are where we set like our XY0 and our Z0 at the machine. I expect you to know 6 of them. There's 100 in the control by default. But I expect you to know the first 6, which are G54, work offset 1, 55, 56, 57, 58, 59. If you know this, G54 is work offset 1. That's what you need to remember. And then when you get on a quiz and you see what's work offset number 3, what I fully expect to see you all do for the first few times, don't try to do it from memory, do this. 54, 55, 56. Okay, 56, G56. All right, just count them out. Don't do it out loud while we're taking a quiz, but do it in your head. 54, 55, 56. Work offset 4 is 57. Does it make sense? These are the first 6, and these are the ones you're going to see on quizzes. Okay, all you really need to know is G54's work offset number 1. It's the most important one. 54 is a really good number. I like that number. No. So on the Herco, our auxiliary offsets, if you hit the auxiliary offset over there, there's 1 through 99 here. They're G54 point whatever offset this is. So auxiliary offset number 1 would be G54.1, G54.2, 0.3, 0.4, and all the way down to 99. Or 90, actually, 94, I think it is. 93, sorry. Down to 93. You can also use variables for offsets. So we're not limited to 99 offsets. We could have up to 99 setups in the forefront of the control. But I could also, if I'm in a big production environment that literally has load and unload fixtures for all kinds of different stuff that we run, and everything's all set up and ready to go, and all I got to do is take fixture A out, put fixture XYZ in, and it automatically jumps to the offset that's set up for that fixture. I can also use my variable tables, and I could actually, they don't say XYZ, but I could do a G and tell it, hey, I'm going to do a G # number sign 500, and it will come here and it'll pull the offset from there. So I can tell it, hey, my X's, I can put my X here, my Y here, my Z here, and then I could use a # to call these variable tables. Has anybody ever heard of macro programming? Okay, that's where we're going there. All right. If any of you already know how to macro program, you're smarter than I am. If I can write a macro program, but only because I've got a little book that's like a cheat sheet that walks me through it. It's what-if statements. So think about formulas you might have learned about in like Excel, doing all those Excel formulas. We can do the same kind of stuff out here in our program, telling it to do, if this part measures this, come in and do a probing routine, and if it measures this, adjust this tool radius by X amount, and then rerun this cycle. Lights out type stuff. Okay, there's guys that do that for a living. They write lights out type programs that go in, measure it in the machine, hands off, nobody touches it. When it lets go of a good part, it better be good, otherwise, somebody's got to go in and figure it out, and that's high dollar stuff. All right, gentleman just passed away, Mike Clodfelter, used to always come in and do a presentation for the class. That was his full-time job. Okay, his full-time job was to go to like John Deere, Caterpillar, Rolls-Royce, high-end places, and set up these lights out stuff. And this guy was a genius. Okay, he was really smart. Cancer got him, unfortunately. Otherwise, he'd be here to definitely visit with you guys. But next level programmer. You know, he knew what we know, what I know, plus all the other bells and whistles that are kind of above my pay grade even. You know, I could probably get there, but I would have to dig in for a while. I'd have to go to that next level of education to get there, and we won't get there during the 2.5 years that you're here with me. We'll get a little taste of it, but you can take it so much further. Off the soapbox, back to work. So I'm back to part programming, Control P. Okay? Remember, all this stuff's up here, but you also have hotkeys that will get you to the screen. The next thing I like to do is I want to put my tool information, and everything I do up here, this is the structure. I'm showing you the structure I want to see you programming in. We get 6, 7 programs in the can, meaning saved in our database, in our archive. We're going to start opening files and going back to that file and doing like a copy and then paste into our new file. When you do quizzes, when I give you your first quiz on programming, I fully expect you to open up your lesson files that are kind of doing the same stuff and not having to write it all out, but copy and paste it in and then modify it. Copy, paste, modify. Okay? CPM. That's my motto. You'll hear me say it more than you want. Copy, paste, modify. We do that in Mastercam. If I've got a good toolpath that works, I'll copy it, I'll paste it in, I'll change the geometry to whatever geometry the part is, I'll make linking parameters or depth adjustments if I need to, regenerate it, move on. You don't have to start rewriting the wheel every time, all right? You don't have to rewriting the script every time, okay? You can use a lot of the reinventing the wheel. Oh, that was a good one. Luckily, the video's on, so we'll have a record of that. So, I'll pause it. Okay. Tools. All right. We're going to use tool number 6, which are 3/8 9-degree spot drill. And we're going to use tool number 7.
Wrong to the blueprint because it's too big. It's a 1/4 inch hole.
What now?
The blueprint is a 1/4 inch hole.
And?
I'm using a 3/8.
Yeah, trust me. I've done this for a long time. I got you. You'll see what we're going to do here in a little bit. We're not drilling through it with a spot drill. We're just spot drilling. We're going to drill through it with a 1/4 inch drill. Okay, so if you can all get that information in there. I don't have to go recalculate those because we did it in our tool library the other day. So I'm just going to go up here to my tool library, tool setup. I'm going to tell it I want to see tool 6. Tool 6 is RPMs 1910 and a feed rate of 7. I'm going to go back to my program. I'm going to plug that in right here, 1910 and 7 on the feed rate. The RPM is a whole number, so you don't have to put the decimal. The machine will not do a half an RPM. It's got to be a whole number. The feed rate, on the other hand, you got to have the decimal after the feed rate. Our controls won't do this, but most controls, most FANUC-based controls will. If you don't put a decimal after the feed rate number, it will automatically round it to whatever decimal place you have the machine set to. So, like, if I was out there on a FANUC control that was set to 4 decimal places, and I put an F value with my feed rate at 7, but I didn't put the decimal after the F, it's going to automatically round that to 4 decimal places and make it 0.7 of an inch per minute. When you go to run the program, you can imagine what that's going to look like. You're going to hit start, and then you're going to be like, nothing's happening. What's going on? And if you aren't watching your DRO, which is moving like a couple tenths every few seconds, you're not even going to think anything's happening. So it's very important that we put the decimal after the feed rate. Some places you need it, some places you don't. This is one you do. Okay. Our drill, we'll go to tool 7. That's 38, 20, and 15. So I'll put that in my comment here. And there's my tool information. I'm an advocate, gang. I'm an advocate for once I've done a little work, and we've been going for 40 minutes or so now, to hit save. So I'm going to jump back over to the program manager and just hit save real quick. And that way, at least that much work, if I kick the cord or something happens to my computer, I don't lose it. Okay. Just anytime. You can do that way more often than I tell you to up here. If every few minutes and I'm kind of paused at a point and you want to just jump over and hit save real quick, do it. It ain't going to hurt anything. Then I can just double click back over to my part. All right, on our header sheet now, new code time. Like I told you, they start sliding in because we're going to start writing programs, and as we use them, we're learning them. Okay, we got to start memorizing them. We got a T with an underscore and an M6. The T is the tool number we want. The M6 is the tool change. It's a miscellaneous code. M6. So here we're going to put T, whichever tool we want, which we want tool 6. Does everybody agree with that? The spot drill first. T6, and then an M6. The M6 will always be an M6. The T number will be whatever tool it is. So when we go and drill the holes on Thursday, we're going to put a T7 M6 to do that tool change. Okay. ATC command, automatic tool change. That's what that is. That's what ATC is, automatic tool change. If you highlight the M6, you can look down at the bottom, automatic tool change request. When I set up a machine, okay, like on a FANUC control, when I'm trying to switch through tools, I'm going into the MDI page because it's the quickest way for me. I type in T, whatever tool I want, M6, tell it to run that, and it brings that tool to the spindle for me. Okay, that's literally just writing a short little line of code telling it I want this tool and spindle. Yeah.
This is maybe a little off topic, but so if you manually program something, would it be very similar to like if I did this on like a Deucin or something like that?
On a different machine?
Yes.
Yeah, we're industry standard. There's, like I said, there's little quirks and stuff and small little things, but I run stuff on FANUC and Haas's and everything else that I make maybe 2 or 3 little modifications to the program to make it run on one of those machines that'll run out here on the Herco. The lathe, there's a little bit more quirks on the lathes. Turning centers, all of them are they've all got their own little kind of flavor, I guess you would call it. We're going to learn the Herco flavor, but I'm also going to say now, here's mode, we do mode B, ISNC mode B. There is a mode A where a couple codes are different, but we'll get used to that. Something else I like to do, I like to take in this comment right here, okay, for tool 6. I'm going to double click on that to where it highlights it, and I'm going to copy it. I'm going to hold down Control and hit C. That's copy on my keyboard. Control C. I'm going to come down here. I'm going to put an M1 optional stop. And then I'm going to hit Control V to paste it.
Well, I completely erased it.
No problem. Hit Control Z. Hit Control Z again. Control Z, hit Control Z again. There you go. Now highlight it again. Okay. Control C. There you go. Now go down there and type in the M1. And hit Control V after the M1 to paste it. Very important hotkeys to know there. Like I said, CPM, copy, paste, modify, is going to be our motto in here. We're going to work off of other programs to build most of the stuff we do. These are Windows keys. These aren't Herco. These aren't WinMax. These aren't Mastercam. Control C is copy on a desktop computer. Control V is to paste. Control X is to cut. Control Z is to undo, which might be your best friend, because there's going to be a day where I tell you to go get something, like what just happened up here to Ross, and you're going to go, oh shoot, I hit the wrong key. Control Z is my friend, undo. or Control U. Well, in here it's not going to do it, but typically in Control U, the redo button. See, here I am acting like I know everything.
Control Shift QQ. No, that's on the book.
Control Y. Control Y is the redo. To redo something you undo. So if you undo it and you want to redo it, Control Y should redo it. Okay? But those are important for you to know. Control C, Control V. Those are the two, and then obviously Control Z when you mess something up. Yeah.
Can you give me 1 second? My crashed.
Your what crashed?
My WinMax. Should I put it?
So, like this right here, if your software crashes or you accidentally close it, as long as the computer doesn't get shut down and restart, it should open back up with everything still there. If the computer the power cord gets kicked out, something like that, and the computer has to restart, you better hope you've saved in the last few minutes, because it's going to restart back at square one. Okay, and then you're going to have to open everything back up. But if you just accidentally close the software, or it gets jumped out of it or crashes, you should be able to open it right back up and be back where you are. While his is coming back up, why am I using an M1 there and not an M0? Optional stop. And what this is at the machine when I'm watching it, when I bring a tool to the spindle, I want to make sure I look at it the first time through and I visually say that's the right tool. I can't tell you how many times students have scrapped parts, people I've seen in industry scrap parts, okay? People that have been doing it for years have scrapped parts because they got their tools mixed up when they were loading them. They went to run the program, and instead of a spot drill, it brings in a 3/4 inch end mill and then plunges down into the part. Okay?
That's not funny. That's
First time through. Okay, the first time through, we want to watch it. The first time through, we got to watch it. The first run through is on us. Good? Everything still there? Good. And let me repeat that. The first run through is on us. It's our job to make sure it's good. When I go out and do my stuff on the side, I set the machine up, I write the program, and I do the first runoff. Meaning I run the machine and make sure that what I did is right before I say, okay, you're good to go. I'll see you later. And then the operator, who has no CNC training at all, or they don't know how to do anything but loosen up the fixture, change out the parts. Take the go, no-go gauge and measure and make sure everything looks good. Once the gauges aren't working, then hey, what do you think? Well, you probably changed the tool. You've been running it for a few thousand parts. It's probably getting worn out. Okay, yeah, we'll do that. They do know how to touch the tools off. That's a good thing. All right, but that first run through is on me. I'm the machinist. I'm the programmer. So I got to make sure that it's good. Okay, so that's where we're looking at it. But I got it on op stop. That way, once I know it's good, I can just shut optional stop off and say let it rip. Okay, wrap it up, turn the feed rate to the 100%, send it. But not until I verify that everything's doing what it's supposed to do. Okay, because I'm just as capable at crashing a machine as you are. If I get careless, I don't pay attention to what I'm doing, and I don't follow what you'll find out is the routine I try to get you into, and then you hear across the shop, and I walk around with my head down because basically I just hit go and wasn't paying attention to what I was doing, and I crashed the machine. Okay, I'm just as capable as the rest of you. All right, but not if I follow my own rules. One of the things that I need to do what I say more often than I do. So, okay. After that, let's look back at our header sheet. We got our tool now. We've got a G90 line, and I'm over here in the drilling because we're working in drilling right now. So I'm over here. We have a G90, which is absolute, right? And then there's a G with 2 underscores there. Well, that's where it wants to know what work offset are we using. So G90 we're going to use work offset 1 primarily to start out. So G54, work coordinate system 1, you see that down at the bottom, work coordinate 1 selection. And we're going to do a rapid interpolation, G0, and we're going to go to hole 1's location. So if I look at the print, hole 1 is this one right here. Okay? So basically, in X, if the center of the part's X0, Y0, we're to the left of that in X, so we're going to be at X minus 1, and the Y is down from the origin, Y minus 0.875. Everybody see that with me when you look at your numbers there and how the points are working out? Think of this drawn into quadrants. You know, we talked about that the other day. If this is our 3 by 3 part and our origin's in the center, split it into quadrants, we're down here in this quadrant, so our numbers are going to be negative, negative. All right? And the distance are given to us right there. So we're going to go to X minus 1, Y minus 0.875. Hole 1 position. Okay. What's that? It's just the color of the X values, X-axis values are this color. Yeah, it's a little bit different. Yeah, it's a different color of red. It's like a burgundy, I guess. Yeah, but no, it's good. It's when we see that color red.
I can see it.
It's just it's a little different, especially if your colors, if you have any trouble seeing colors, then probably try not to let those bother you too much. If I try to run this and I've got something that's no good, it's going to say invalid keyword, and it's going to jump to that line and tell me you got something here you got to fix. So right here I say jump to block, it'll jump to that block, and obviously this is no good. So those that have programmed the CNC before are going to find out that this control is really nice on that too. If there is an error, on the mill especially, it'll pretty much jump to where the error is at and kind of isolate it to one line, where if you've programmed on other controls, it'll tell you there's an error, but it doesn't take you right to it. It just basically says you got a problem in your program somewhere. And then you got to sit there and line by line. I love that about this control, especially for this first year manual programming class. All right, the next thing we're going to do, we're going to move down. We're going to check our tool length. So G43, what was that? Tool length compensation. Tool length compensation. G43 on our header sheet. Next to it, it's got a, what letter? H value. The H should be the same as the tool number. So H6. Tool 6, H6, we call that H&T agreement. They should always be the same. I am not a fan, and I have crashed a machine out here when I was a student because the instructor I had programmed a part. We had tool 12, I think it was, and for the roughing he had it as an H12, and then for the finish cycle he changed the length value to H22, but he gave it to me to go set it up and run it. I didn't know he did that, and I didn't put anything in the 22 register. So when I went out there to run the thing, it got to the finish pass, everything was roughed, looked good, all I had to do was finish, and it got there and it went because it was 0. So it tried to go through the part with a inserted body face mill or inserted cutter. Yeah, so H&T agreement, try to make sure, keep those matching, okay?
How big was the cutter?
I forget. We're going to come down to 2 inches above the part. So I'm going to put a Z2. And I'm also going to put in this line, I'm going to put a G1. I'm going to do this at a feed rate. Linear move, so I can do it at a feed rate, not a rapid. And usually I set that feed rate at 50. It might even be what that is on your sheet. Nope, doesn't have it on your sheet. So this is what this line usually looks like to me. 50 inches a minute coming down to check that out. And then I'll put another M1 verify tool length. I'm going to take a 2-inch 1, 2, 3 block, slide it over there with that. It's going to be stopped right there at that op stop. It's going to let me slide it over and make sure the tip of my tool is 2 inches above the part, which makes me know that my tool length is set correctly. Okay, that's what I'm doing there. All right. Okay. Once we've verified it, give me the next. Let's see here. Who can I pick on? Huh? You don't want picked on? All right. Jack, what's the next line there?
MO1.
What's that?
MO1.
After the M1.
Oh, it's
The S. Okay. The S is our spindle speed. So our RPM for this tool was 1910. So I'll type S 1910 with an M code, M3, which is what? Ta-da. Spindle on clockwise. Okay, spindle on clockwise. All right. Spindle on clockwise. So let's see here. All right. That's what the M3 is. Spindle on clockwise. Okay. All right. After that, we've got the spindle on. We're ready to move to our initial height because we're going to do the can cycle. We're real close. We're only about 6 lines from having these all spot drilled. Okay, and I know it doesn't seems like there should be a lot more, but we're pretty much there. This stuff up here, guys, gang, this structure and what you see here, you remember how I keep talking about copy and paste to make some changes? We're going to copy and paste most of that to our next program we do. And then we're going to make some changes to it. That way we don't have to type it all. You know, even though we're manual programming, doesn't mean we have to do everything every day. You know, I don't care if you type like Mr. Wallace.
My dad does that way too.
Okay? If you type that way, then that's fine because copying and pasting is pretty easy. Okay? And he's a king of copy and paste. Only he does it with scissors and glue sticks and the old way. Still can't believe you let his head get all inflated like that this morning. I'm sure he does, yeah.
Wait, what?
Oh, he comes down here and tells us about how riveting Mr. Wallace's lecture was this morning and how much he enjoyed it and how it had him on the edge of his seat. And it's a running joke with me and Mr. Wallace because I lecture every day. Those guys get a lecture some days, and then some days it's like, let's go to work. I don't get very many let's go to work days. Usually it's I gotta get up here and talk for a while. So, okay. We're gonna look at our header sheet again. Once we've verified that, we're gonna come to the initial height. Now it's at 0.1, but I'm gonna tell you, let's do 1 inch. Let's come down to 1 inch above the part. That's gonna be the initial height. Okay. Then what I'd like you to do is we're going to type in our can cycle. Okay, so we're going to go right off that line and I'm going to have you plug in these values. We're already at the X and Y position of hole 1, so we don't have to put that in the line. Wherever you're at when you start the can cycle, or if you put it in the can cycle line, that's where it's going to put the first hole. So since we already moved there up here, we're there, we don't have to do it again. You don't have to repeat anything. If you're already there, you're already there. I'm going to do a G98 initial height return. That basically means that between each hole, it's going to go back to 1 inch above right here. I'm going to do a G82 spot face counterbore cycle. Okay, on your sheets, not sure what it says, but should be something along those lines for G82 on your G&M code sheet. Okay, spot face counterbore cycle. The next thing it wants is the depth. How deep are we going to spot drill? Okay, so in our little books here, go ahead and pull these out. We're drilling aluminum. Page 24 is what I want you to look at. Okay, 24 is what I want you to look at. Everything's an equation with us. We're dealing with absolutes here. All right, it's not like a drill press, take a look, measure it with your scale, and I'll hit it again. Yeah, that looks good. That's not what we do out here. We calculate stuff. You know, and then we fine tune those numbers. So on page 24, you see at the bottom it says hole chamfer depth formula. It's a 90-degree spot drill, so there's a 90-degree option. It says 0.5 times the chamfer diameter equals the point depth. So our hole is going to be a 1/4 inch. And let's say I want a 20 thousandths per side chamfer. So I would add 40 thousandths, because that's what the top of my chamfer needs to be, right? I would add 40 thou to this. That'll give me a 20 thou per side. So the overall chamfer, big part of the chamfer, or spot drill, is going to be 290 times 0.5. My depth I'm going to go to is 145 deep. So we're going to do a Z minus 0.145. Minus 0.145. You got to put a negative there because we're going Z0 down into the part, 145 thou. Then the next things are R plane. The R plane is also what I call the feed plane. Okay, the retract plane, the feed plane, retract plane. We're just going to set that at 100 thou, R.1. That's our R plane. Absolute Z level at which machining begins. Basically from there, it's gonna wrap at 2 there, and then from that point's where it starts feeding at the feed rate that we're getting ready to tell it. Because we got to tell it, it's still set. Right now, if we don't tell it a feed rate, how fast is it going to feed? 50. 50 is modal. That's a modal. Until I give it a new feed rate, the feed rate's 50. Okay, the only time it's not going to feed at 50 until I give it a new feed rate is anytime I have a G0, and then it's going to go as fast as the machine will go. Okay, because G0 is rapid. I'm going there as quick as I can get there. We do not want to spot drill at a G0 rapid move. Okay. All right, so we're going to tell it a feed rate, and the feed for this tool is 7 inches per minute. F7 point. Okay. Go down 2 or 3 lines with me and put a G80, and then right after that do a G0 Z2. Okay. Once you've got that, go to Program Manager and save your work, just in case. Let's just save it one more time there. Then I want you to click on the little Herco circle down there at the bottom. Before you hit play or anything, I want you to click on over here, click on ISO. You should see the part like this when you click on ISO. If you don't, click on ISO or hit the refresh button here. And then click on ISO, and let's see if everybody's material shows up like it should. You might have to hit play first. I don't want to hit play. Hit the play button after you go to the ISO. There it is. Yeah, hit the play button. That should make it show up. So you should, when you hit play.
Wow, I can send a
Yep.
drill.
Sorry. You should see the spot drill on the screen. So go to ISO over there. To the right. Right there. Right there in the views down. 2 more holes to spot drill. We got to do all that 2 more times. No. No. We're using a can cycle. So here's what we're going to do. Back over here to our program. In between the can cycle and the G80, we're going to tell it where the other 2 holes are at. We're going to tell it X0, Y0. Hole 2. We're going to tell it X1, Y 0.875. Hole 3. Okay. The can cycle is active, which means, and I said this is why anytime it's active, any position you move to, it's going to repeat what we did there at that location. It's going to repeat that. Now, if you go draw that now, just hit play again. Boom. As the old Titan Gilroy would say. Boom. We spot drilled 3 holes. Strongly encourage you, and I will send the link out to this, to learn about this graphics screen. There's a lot of stuff this can do. I can sit here and I could rotate this drawing around dynamically. I can zoom in and out on stuff. I can click on the zoom button up here and tell it, hey, I want to look at this part. But here's one I really like. I love this part of it. Okay. I can come in here and I can hit the reset button. Kind of get that center back up. And let's say I want to jump to a line of code. This is something that most controls don't do. I want to go and I see something going on and I want to look at that line of code. Okay? I can come over here and I can come down and hit select. And I can pick that line of code. Or, let me find it here. It's not measure, it's not fill. Where is my, oops. Well, it should go to it for me. Okay. I can click on that and tell it to jump, and it will jump to it in my program for me. You'll be able to see that better when we do some milling. You can click on segments of your milling. If you see something that's not doing what it's supposed to do, you can hit select, click on the line of code or the movement in the graphics screen, tell it to jump, and it will jump to that part of the program for you so you can check your values and make sure they're good. Okay, there's all 3 spot drilled. Now watch this. Notice how it's going up way high and this part's flat and there's nothing in the way. I'd say, man, that's a lot of extra movement. Why is it going 1 inch above? Well, watch this. Just change this to G99, which is our plane return, and then go back and hit play again. Just by changing that from a 98 to a 99, it's no longer retracting up to 1 inch above. Now it's just going to the R plane, rapiding over to the next hole, spot drilling, and doing its thing. Okay. Simple little things can change a lot. I'm going to put that back to G98. Make sure it looks good still. Okay. And then I'm going to go to Program Manager and I'm going to hit Save. Okay. That's where we're going to leave off today. Yeah.
Can you pull that back up? Mine's
Yeah. Okay. All right. One thing I do want you to do, don't close it. Hold on. I do need you to do one more thing. We need to go, like I told you, if we don't put the in % sign and we save it, when we open this back up, it'll be blank.
Ah, shit.
I don't need you cussing in here.
Sorry, I might have. This may have saved it.
Just let it open back up. It's still there. As long as you don't restart the computer. Okay. I'm gonna put a swear jar up here, and when you cuss, I'm gonna start making you put money in it.
Okay. Thank goodness I got some quarters.
I take 5s and 10s only. No change.
Okay.
No. I'm gonna do the single. Alright. So what I want you to do is go all the way down to the bottom right above the E and put the end. Notice when I hit that, see how that E right there ended it? That's what I want to see. So put that percent at the end and then save it one last time. We'll get you. You're all right. It's not the end of the world. Just let it open back up and then we'll go to the bottom and it's still going to be there. Until the computer gets shut down, it's still there, but
Where's his power cord? Do not even think about it.
all right. If you scored under a 24 on the calculator quiz, okay, if you didn't do a better than a 24 on it, let me make sure that that's the number I like. 24 divided by 28 was an 85. 23 divided by 28 is 82. So if you scored 23 under a 23, you need to retake the calculator quiz right now. Okay, if you scored 22 or less. If you scored better than that, but you want to retake it because you know what you did wrong and you know you could do better, go ahead. Retake it. It's on. It's available to you. Okay, you can redo it. If you scored 27 and you're happy with that, you don't want to spend the time in here and do it, you want to take off, you're free to go. Okay, but it is on right now for you to retake. The goal is 23 or better. Okay, the goal is 23 or better. If you aren't able to do that today, we are going to sit down and try to figure out what we need to do to make sure you do. Okay?
If you retake it, you get a lower score without.
It, highest score. It's going to take the highest score. Yeah.
we need to save that to our thumb drive.
So once you've saved this, yeah, let's talk about that. Once you've saved this, all right, thumb drive, I plug it in. And here's what I do to update my thumb drive. Once I've got it plugged in, I just go to my thaw space, and this is Luke Ferris's, but I'm going to do it anyhow. I find my folder on the T drive. I right click on it, go to send to, and I send it to my thumb drive. If it pops up and says, hey, you got other files already here that match these, just tell it override them or copy and replace. Replace files in destination, because everything we're putting there has either been updated or modified. And even if they're the exact same files, who cares? Let it override them. Just make sure you got the most current. Did you get that percent sign at the end?
Yes.
Okay. All right. Machinist calculator quiz is up. You can take that. If you did good enough that you don't feel like you need to, you're free to go.